Alright, so this is chapter 3, section 3, and we're going to be looking at some properties of logarithms. Now, in section 2, we looked at some of the properties, and we're adding to that list now. So if I have log, this should be a base b, of m times n. So I have two things being multiplied here. Then what I can do is I can separate them so that we have log base b of m plus log base b of n. So this right here would condense, addition would condense to multiplication. Similarly, if I have log base b of m over n, then it can expand to log base b of m minus log base b of n. So subtraction condenses to division, and division expands to subtraction. Now we can use the power rule here, where if I have log base b of m to some power, that p, that exponent there, can come out front and be multiplied. Now this is a very common mistake here. People think that if you have log base b of m plus n, that that's the same thing as separating it. You can't do that. That's not the same thing. Okay, so if we have a product, then it expands to addition. We can't expand addition here. Below this, we have the change of base property, where sometimes we want to change our base. If you have like a TI-83 calculator, it will not allow you to take the log of anything other than base 10. So let's say you had a base 5. Well, we can change the base to whatever you want. You're choosing the a value, you're choosing the new base using the change of base formula here. Now you can use it with a regular logarithm, making it a different base, or you can use natural log. So let's go ahead and get into some examples here. This is a skill that you should have done in Algebra 2, so hopefully this will be a little bit of a review. And if I have a log with base b here, and I want to expand all of this, I have two terms being multiplied here, so that can expand to log base b of x plus log base b of y cubed. And if you stopped right here and said this was your answer, you'd get half credit, because this is not expanded all the way. This exponent right here can come out front. So we have log base b of x plus 3 log base b of y, and that's expanded all the way. We can look at a little bit more of a complicated example. We have natural log of x cubed times y over z squared. So division expands to subtraction. So natural log of 3 of x cubed y minus natural log of z squared. Now this square can come out front, and this product here can expand. So I have natural log of x cubed plus natural log of y minus 2 natural log of z. Almost there. This 3 can come out front. 3 natural log x plus natural log y minus 2 natural log z. That would be full credit. That's expanded all the way. Our next one here is a fun one. It's very complicated, lots of different pieces here. So let's go ahead and look at this and go through each step here. So I have a few terms on top and then some terms on the bottom. Natural log of 100x to the third cube root of 5 minus x. And then we have minus natural log of x plus 3 to the 5th power. Now, just like we saw above, I can't expand this, but I can move the 5 to the front. And here, I can expand all of these terms. So let's expand them. Natural log of 100 plus natural log of, let's see, x cubed plus natural log, and remember, writing something to the cube root is the same thing as 5 minus x to the 1/3 power minus 5 natural log x plus 3. Now the only thing we have left to do is to move some exponents out front, and then we're done. So I have natural log of 100 plus 3 natural log x plus 1/3 natural log 5 minus x minus 5 natural log x plus 3. And that's it. That would be our final answer. So that's expanding. Now going the other direction is called condensing. We can condense a logarithmic equation. So looking at this first example here, we said that addition condenses to multiplication. I also see that that 7 can go up on the y here. So I have log x plus log y to the 7th power, and then log xy to the 7th power. And that would be my answer. Okay. Moving on to the next one, I noticed that this exponent here can go back on top, and this one can as well. And now what we can do is say natural log of x plus 9 to the 8th power minus natural log of x to the 4th power. And we have condensed it part of the way, not all of the way yet. So condensing it the rest of the way, we see that subtraction condenses to division. So natural log, and now we have x plus 9 to the 8th power over x to the 4th power. And that would be condensed all the way. Our next example here, we have a long, complicated example, so let's go ahead and work it with this from the inside out. So this 5 right here can go back on here, and then we can condense this. And we have this term right here. It's going to be helpful for you to start looking at whether terms are positive or negative. If this is a positive 5 out front, then that means that this is going to be in the numerator. But because both of these are subtracted, they're both going to be in the denominator. So we have x plus 6 to the 5th power. And then since these are both being subtracted here, they condense to division. And this is really almost as far as we can get things. If you stopped here, you'd probably get half credit. But we still have this 1/3 out front, and that can go on top of it. Now, bringing this 1/3 up here, well, having the 1/3 power is the same thing as taking the cube root. So I can rewrite this as natural log cube root of x plus 6 to the 3rd power, or to the 5th power, over x times x squared minus 25, and that would be our final answer. Okay. Now this last example here says use common logarithms or natural logarithms and a calculator to evaluate to 4 decimal places log base 6 of 17. I'm going to use a natural logarithm. And we're using the change of base formula here. So log base 6 of 17 can be natural log of 17 over natural log of 6. This is your exact answer. This is part of your answer. I do need to see that as part of your answer. And then the decimal that we get is our rounded answer. So we have natural log of 17. Close the parentheses, divided by natural log of 6, close the parentheses, enter, and we're rounding to 4 decimal places. So we're rounding to 1.5812. Both of these are my answer, and that is the end of section 3 for chapter 3.